everyone, in this video we're going to be going through LeetCode problem number 112, which is path sum. Now path sum states that given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. And a leaf is a node with no children. So in example 1 here, we have the binary tree 5, 4, 8, 11, then null because 4 doesn't have a right branch, 13, 4, 7, 2, null for left branch here, null for right branch here, and null for left branch here, and then a 1, which is how you read this root value here. And the target sum we're looking for is 22. So 5 plus 4 plus 11 plus 2 equals 22. So that returns true. In example 2, target is 5, and this is false because we can get there 2 plus 1 is 3 and 3 plus 1 is 4. There is no root to leaf path that gives us 5. And the third example is actually false. Target sum is 0 because there is no root or leaf. Okay, so let's see how to do this. So we're given a method called hasPathSum. We're going to pass in the root, a tree node root, and an int sum, which is the value we're trying to get to. So the first thing we're going to do is if root equals null, which was what we saw in the third example, then we're just going to return false. Then we're going to take sum and subtract the value of the root. So now if root.left equals null and root.right equals null, which means we've hit a leaf node, return sum equals 0. So this is saying if we have a leaf node here, return either true or false if the sum is 0 or not. And this will tell us to keep going if the sum is not equal, if this returns false. Otherwise, we're going to return, and we're going to call hasPathSum again. Surprise, surprise. Binary tree uses recursion. It's usually less lines of code, but way more confusing. So this is going to call pathSum with root.left and the current value of sum. So as we subtract out, as we decrease the value of sum, we pass that into the next instance of hasPathSum. Or hasPathSum root right and pass in the sum. Now this can be a little confusing because you're basically saying, pick one, either this one or this one. But we'll always do the what's on the left of the or sign first. And that is pretty much it. So let's see how this works in the code. In my handy dandy chart here. So I recreated this example 1 here. And if we step through, so the first thing we're going to do is look at the 5, value 5. So we're going to subtract the sum, which is 22. We're going to subtract 5 from that, so sum becomes 17. If root left equals null, is false, and root right. So one thing to note here is when you have an AND condition, both sides have to equal, or have to be true. So if the left side is false, there's no need to check the right side, because there's no way it could be true if one side is false. Okay, so now we're going to call hasPathSum. Because this is not subtracting the root value from sum did not give us 0, so we have to continue on and check the left. So now we're into the 4. The root is not null, so we're going to subtract the value 4 from 17 to get 13. Root left, again, is false. So now we're going to call the root left of the 4. So now we're into the 11. So we're going to subtract 11 from 13 to get 2. And again, the left is not null. So we're going to call has path sum with root left. Now here this gets interesting because now we're dealing with 7. So if we subtract 7 from 2, we're going to get negative 5. Okay, so here we go. So the left is now null because 7 doesn't have, it's a leaf node, it doesn't have a left or right branch. And the right is null, return sum equals 0, that's false. Okay, so now it backs us up to the 11. And now we're going to take the right value, so we have the 2 here, which is right here. And let's go into that. Now, root left is null because this is a leaf node, no left or right branch, and root right, and sum equals 0 is true. Okay, so now we have our answer, but we still have all these instances out there, so we have to close those out. So this is the 11. Now we're back to the 4. And this is closing out the 5, which is the root node. So now we go up here, and we have the result of true. All right, let's run this through the LeetCode. Let's see what we get. Accepted with that same example I just went through. And if we submit it, not going to run that one again. Faster than 100% of all submissions. Alright, so the last thing we'll go through here is space and time complexity. So this is O of n, where each node could be visited once. A worst case scenario would have to go through all the nodes. So as you get more nodes, you get it takes longer to go through them. Space complexity is also O of n, the space needed for each of those nodes. As you get more nodes, you need to take more space. And that is pretty much it. Thank you for watching. Let me know in the comments if you have any questions. Good luck on those interviews, and we'll see you next time.